Okay, so we are going to find the position vector of the foot of the perpendicular from the point P 393.6 to the line. Alright, so this is actually a question involving the foot of perpendicular from a point to a line. Alright, so it's a foot of perpendicular from as well as a perpendicular distance from the point to the line. And so the general idea is like this, right? So supposing, right, we have a point here, right, and then we have a line. Okay, so what we need to do is we need to find the foot of the perpendicular, maybe point N, from the point to the line. Okay, so the general idea is like this, right? So because this N, right, it lies on the line, maybe A plus lambda M. That means, right, this N, right, this position vector of ON, right, can be written as A plus lambda M, right, for some lambda. So that's the idea that we have. Because it lies on the line, it can be expressed in terms of the line. And then from there, what we're going to do is next we will find Pn. We find Pn, alright, in terms using ON minus OP. Alright. And then after that, right, we take Pn dot product with the unit the direction vector of the line. Okay, because we know that this will give us 0, and from here, right, we can find the lambda, which gives the n, which gives on. So this is the general strategy where we are always finding the foot of the perpendicular, right, from a point P to a line, right, using the expressing Pn and then finding the dot product to give us lambda. So with that, let's come to this question. We have BMQ question 12. We have the position vector of the foot of perpendicular from point P -3, 6 to the line 8, 7, -2, 3, 2, -2. So from here, we need to find the perpendicular distance. We need to first find the position vector. Alright, so very quickly, we go on to the next portion. If we are going to do this, right, so let's draw the line first. This is our line here, right? This is R, which is equals to 8, 7, -2, 8, 7, -2, plus lambda of 3, 2, -2, where lambda is a real number. Okay, with that, the position vector P is 3, -3, 6 is over here, right? So basically what I do is need to first find the position vector of the foot of the perpendicular. Alright, so okay, after that, right, since ON, right, since N lies on the line, right, that means, right, ON, the position vector of N, can be written as 8 plus 3 lambda, 7 plus 2 lambda, and -2 minus 2 lambda. Because it lies on the line, it can be expressed in this form, right, for some lambda, not for all lambda, for some lambda. Okay, and then next up, right, if we can find ON, right, what we can do is we can find Pn. So similarly, right, Pn, okay, this will be just ON minus OP. And what is ON? ON is just your 8 plus 3 lambda, 7 plus 2 lambda, -2 minus 2 lambda. Subtract away OP. OP is just equals to 3, -3, 6. Okay, and with that, you should have your Pn to be 5 plus 3 lambda. Okay, 10 plus 2 lambda, and -8 minus 2 lambda. Alright, next up, so we know that our Pn can be expressed in this form for some lambda, and actually we also know that if we dot product Pn with the direction vector of the line this will give us 0 since they are perpendicular, right? So this means that 5 plus 3 lambda, 10 plus 2 lambda, negative 8 minus 2 lambda, dot product with 3, 2, negative 2, right? So remember 3, negative 2 is the direction vector of the line. It should give us 0. This means that if you have a 15 plus 9 lambda plus 20 plus 4 lambda plus 16 plus 4 lambda should give us 0. Okay, so very quickly this means that 17 lambda, so simplifying the algebra, here you have lambda to be equal to negative 3. Okay, so with that, right, quickly you know that since on right is equals to 8 plus 3 lambda, so 3 times of negative 3, 7 plus 2 lambda, 7 2 times of negative 3, minus 2, so negative 2 minus 2 lambda, so 2 times negative 3. Alright, very quickly, so this is 8 minus 9, you have negative 1, 7 minus 6, 1, negative 2 plus 6, which is 4. This is your on. Okay, and next up, right, we are done. We have actually found this. Okay, we actually found this, right? So this is negative 1, 1, 4. And next up, we need to find the vertical distance from P to L, right? So basically, what they want us to do is they want us to find Pn. And they also find the length of this, right? Basically, this is the vertical distance from point P to L. So Pn very easily. Pn, right? First, let's find Pn. Pn will be equals to 5 plus 3 times negative 3, 10 plus, using this formula, right? Using this formula, okay? And we sub our lambda, which we have found, negative 3. Right, so 10 plus 2 times negative 3 minus 8 minus 2 times negative 3. Okay, your Pn should give you negative 4. 10 minus 6, 4, minus 8 plus 6, negative 2. Alright, so very quickly, the magnitude of Pn would just be negative 4 square plus 4 square plus negative 2 square, right? And it should give you quickly, it should give you 6, right? So that's the perpendicular distance from point P to L. Alright, next up, we have to find position vector of P prime. Okay, so suppose this is our L, right? Our P prime is here. So this is the P. Okay, the next one is P prime is somewhere here. Okay, so this is the reflection. So bear in mind that N here. Alright, N as we have found. Okay, N over here is actually this is actually the point negative 1, 1, 4. P as we have found just now as well. OP, right, can also be found. OP is actually 3, negative 3, 6 from the question. Alright, so if I have this, okay, one thing you must remember that since it's a reflection, it means the distance, this distance and this distance should be the same, because we are talking about reflection. So if you go backwards, right, we are actually talking about ratio theorem. If I were to put Pn compared to N, Pn prime, P prime N, right, the ratios are 1:1. Alright, so every time you see a reflection, usually it involves using ratio theorem. Okay, when you see a reflection kind of a question, right, highly likely you can use ratio theorem to help you. So using ratio theorem, alright, remember that actually On, sorry, this is just equals to OP plus OP prime, right, divided by 2. Okay, so On, which is negative 1, 1, 4, right, is equals to OP, which is 3 minus 3, 6, plus OP prime over 2. Okay, and very quickly you can just simplify. So OP prime, you should have 2 times of negative 1, 1, 4 minus 3, negative 3, 6. That should give you your OP prime, and very quickly your OP prime should be equals to should be just equals to negative 5, 5 and 2 after computation. Okay.